So what are some of the primary testing techniques? Well, we do unit testing, or testing individual pieces of code. We also test all of the interfaces to make sure that all of the pieces communicate effectively. We don't want a situation where data going from one application or one module to another maybe moves from a different format. If we change the format from numerical to alphabetical, or we change the size of the field, we could easily end up in losing data or having contamination of our process itself. We then test the system. Make sure that, well, we've done things like load testing. Load testing would be, will this system continue to work under what we consider to be the anticipated load, the amount of work or transactions, or how busy do we expect this system to be? Will it work correctly under a normal load? And that would include, we'll look at network bandwidth, we'll look at CPU, we'll look at memory, we'll look at the efficiency of database calls. This is really where we're testing. Then we can say, how will this system work in a way that should reflect real-world everyday activity? We're testing its performance, its response time. How well does it handle any type of errors and exceptions? But it's also important that we do stress testing. Stress testing is when we test it with an exception well beyond what we would have anticipated. To go back to the analogy of an aircraft, when Boeing or Airbus builds an airplane and they do the initial testing, they certainly test it for what should be its performance under anticipated normal conditions. But they also will test a wing by lifting it up, stretching it to see under what point of stress could that actually then fail. So we know then not only the anticipated performance of the system under normal conditions, but how much can exceed, or in some cases not meet those normal conditions and still perform properly. Then, once we've tested each individual piece, we've tested the integrated system, we've tested to make sure our system's working correctly, we will now test it from the perspective of the user. And user acceptance testing will of course now be to check, will this system be functional according to what the users actually require? We'll test for the quality of the system, for example. Some of the additional types of testing techniques we'll use: alpha and beta testing. Very often alpha is internal, with some of our internal staff just testing the program out. Whereas a beta test might be to even some of our customers that offer to help us with testing this proposed new product. When a customer tests a product for us, they're doing a black box test. A black box is where they're basically, the system or the application is just an entity they are using. And with a black box test, all we're really testing is the functionality of that system or of that unit. They don't see how it works inside. They don't have visibility beyond, when I put in a certain input, what is then the output. When we do a white box test, we have the ability to look in at the code. We can test each line of the code to make sure it is executing as we anticipated. We can insert little variations to see whether or not the program handles those exceptions or errors properly. An important type of test to do is regression test. Quite often we'll use similar test criteria and similar test data when we do our various tests. This will allow us to test, for example, that if we've made a change to one part of a program, it does not then affect the operation of other parts of the program. The other thing we'll check with regression testing is we'll test to make sure that we don't then bypass or override previous changes. This has happened in the past where, for example, a company has rolled out a change, a fix for a problem, but at the same time there are larger initiatives going on to change core functionality of that program. But unfortunately, that larger project was not aware of this minor change that had been made and then reintroduced that problem again, when their implementation came around. This is why we want to do regression testing. We'll also do parallel testing when we can. Parallel testing means that if we have a program that's a new system that's coming into readiness for implementation, we'll actually run that new system while we are still running the old system as well. So we make sure the new system is working correctly before we turn off the old one. We test and, of course, validate each function to make sure that, well, the program does what it said it would do, and also we verify to make sure that those functions are working correctly. We quite often use those terms validation and verification. Validation is to make sure that each utility or service or function is working. Verification is then to check to make sure those are the right functions, that we're doing the right things. These are important for an auditor. We don't just check to see whether or not something was done, but are we really doing the right thing? The other thing is we have to test our system in its operational environment. This is what we call sociability testing. And this is where we're looking at our system to make sure, does it work or play well with other systems? If I bring in, for example, a new application that doesn't communicate effectively with other applications, doesn't really work well in the network architecture we have, then we have a sociability issue that certainly should have been considered and must be addressed.